Welcome to lesson 33 about basic integration rules. We are going to practice these rules of integration with these 13 problems. Let's go to start. Evaluate the integral of 9 divided by t minus 8, everything squared. This looks like substitution will solve the problem. So let's name u equal t minus a. If I name u equal t minus a, I will have an equation that will be 9 divided by u squared. And what is ddt? Well, ddu is equal to ddt. So ddt is ddu. So the integral of 9 divided by t minus a by t minus a squared ddt is the integral of 9 divided by u squared ddu. This is 9 times the integral of u minus 2 ddu. This is 9 times the integral of u minus 2, or the antiderivative of u minus 2, is u minus 2 plus 1 divided by minus 2 plus 1. But minus 2 plus 1 is minus 1. So it would be u minus 1 divided by minus 1, or minus 9, 1 divided by u. And the problem is not solved yet. The problem says that u is t minus a. So it will be minus 9 t minus a plus c. And now the problem is solved. If you want to check, you can do the derivative of this function of minus 9t minus a, and you will obtain the integral. And the problem is solved. Now, the second problem is evaluate the integral t squared minus 3 minus t cubed plus 9t plus 1. What I see is a function in the denominator, and in the numerator, what I see is something similar as the derivative of the denominator. So maybe substitution will work. So let's go to name u like minus t cubed plus 9t plus 1. If I name this, the derivative of u respect to t will be minus 3t squared plus 9. So ddu will be minus 3t squared plus 9 ddt. And now I have to rewrite the integral in terms of u. T squared minus 3 divided by minus t cubed plus 9t plus 1 ddt will be equal. Now, if we take factor common and ddu the number 3, ddu will appear like minus 3 that multiply t squared minus 9 ddt. And t squared minus 9 ddt, t squared minus 3 by 3, 9. Minus multiplied by minus plus. And t squared minus 3 dt3 is ddu divided by minus 3. So t squared minus 3 ddt is what is in the numerator. So it will be ddu divided by minus 3. So this integral will be the integral of t squared minus 3 ddt minus 1/3 ddu divided by minus t cubed plus 9t plus 1 divided by u. And this is minus 1/3 by the natural log of u. Plus c. And now the answer would be equal to minus 1/3 natural log of u, but u is minus t cubed plus 9t plus 1 plus c. And this is the final result. If you want, you can try to do the derivative of this function, and you should find the integrand of the integral. You should find this expression, this function. Okay, next problem. Now, this problem is also substitution. If I name you the denominator 1 plus e to the x, the derivative of u will appear in the numerator. So let's go to do it. 1, it will be 1 plus e to the x. The derivative of u respect to x will be, the derivative of 1 is 0, the derivative of e to the x is e to the x, the derivative of u respect to the x is e to the x, so ddu is e to the x ddx. And this is what it appears in the numerator, so the integral of e to the x, 1 plus e to the x with ddx will be equal e to the x by ddx is ddu. And 1 plus u to the x plus e to the x is u. So the integral of ddu divided by u is the natural log of u. So the solution is natural log of u. 1 plus e to the x plus c. And the problem is solved. Now, this integral, we perform long division. When you have a polynomial like x squared and you divide by another polynomial, you use long division. And long division say that the result of the division of two polynomials is not a polynomial, is a function. It is a function that contains normally an asymptote. So the idea is when you divide 11 between 2, you know that this is 5, 5 by 2 is 10, and the remainder is 1. So the equation is that 11 is 5 multiplied by 2 plus 1. 5 multiplied by 2 is 10, 10 plus 1 is 11. So basically you multiply the 5, let me erase here this point. You multiply the 5 by the 2, 5 multiplied by 2 plus 1. So with functions that are polynomial, you divide p of x, the polynomial p of x, by the polynomial q of x, and you will obtain c of x and a remainder. And the equation that you have to write is that p of x, this, is equal c by q plus r. C multiplied by q plus r. So in this case, p of x is x squared. Q of x is x minus 1. And the division say that c of x is x. Then the long division will say that x squared divided by x minus 1 is x plus 1, and the remainder is 1. You practice long division. So in this case, the p of x is x squared. The c of x is x plus 1, and the q of x is x minus 1, and the remainder is 1. So x squared divided by p of x divided by q of x by x minus 1, if I divide this equation 1 by x minus 1, I will obtain x plus 1 divided by x minus 1. And this is the equation that I have to integrate, because certainly will be more easy to integrate in the right side than in the left side. So let's go to do it. So the integral will be the integral of x squared divided by x minus 1 ddx will be equal to the integral of x plus 1 plus the integral of 1 divided by x minus 1. What will be the integral of x plus 1? X squared plus x. What will be the integral of 1 divided by x minus 1? Natural log of x minus 1. So plus c, and this is the result. Let's go to the next problem. Okay, to do this integral of 1 plus sine of x divided by cosine of x, you know that we can split the numerator. We cannot split the denominator. So if we split the numerator, it will be 1 divided by cosine of x plus the integral of sine of x divided by cosine of x ddx. So this is the integral of secant x. Secant is the reciprocal of cosine of x ddx, plus the integral of tangent x ddx. Now we have to find the antiderivative of secant x. And to do the antiderivative of secant x, there is a trick. And this is the trick. The integral of secant x ddx is equal to the integral of secant x multiplied by secant x plus tan x divided by secant x plus tan x. So I multiply by 1 by ddx. What I get now, I get that I'm resolving the integral c. So it will be secant square of x plus secant tangent of x divided by secant x plus tangent x. And now let's go to name u as a secant x, plus tangent x. If we name u as a secant x tangent x, the derivative of u respect to dx will be the derivative of secant x. The derivative of secant x is the derivative of cosine of x, and the derivative of cosine of x is sine of x divided by cosine square of x, or in other words, it will be sine of x divided by cosine of x multiplied by 1 divided by cosine of x, or in other words, tan x secant x. Oh, but tan x secant x, it appears in the numerator, so the derivative will be secant x tan x plus the derivative of tangent x. The derivative of tan x is secant square x. Oh, but secant square x appear in the numerator. So this integral looks like the integral of 1 divided by u by d du, because d du is secant square, d du is secant x tan x plus secant square x ddx. This is d du. So the integral of secant x is the natural log of u. And the natural log of u is the natural log of u of secant x tangent x. So, as a result, we have found the first integral. The integral of secant x ddx, this integral. And now we have to find the integral of tan x. Now, the integral of tan x is more easy than the secant x. The integral of tan x is the integral tan x ddx is the integral of sine of x divided by cosine of x ddx. So what I see is the function in the denominator, cosine of x, and the derivative of the function in the numerator with the minus sign. So this should be minus the natural log of cosine of x, because the derivative of the natural log of cosine of x will be 1 divided by the function 1 divided by cosine of x, by the derivative of cosine of x, that will be minus sine of x. With this minus will be the integral. So as a result, the conclusion is that the integral that we want to find, the integral of 1 plus sine of x divided by cosine of x, is equal to this integral, and we found that the integral of the secant x is the natural log of secant x plus tangent x, secant x plus tangent x, and the integral of tangent x is the natural log of cosine of x, and the integral is solved. You may wonder, wow, how you know that multiply by 1 in this form you can do the integral? I don't know. I just read it I just saw in the textbook that this is the way they found. The tricky way to do the integral is it needs a lot of imagination to find this integral. But once that you practice and you redo it, you can create this kind of solution. Okay, let's go to the next problem. Next problem say evaluate the integral of 1 divided by cosine of theta dd theta. What will you do in this integral? It looks very difficult, but see this trick. The integral of 1 divided by cosine of theta minus 1 dd theta is equal to the integral of 1 divided by cosine of theta minus 1 multiplied by 1 and dd theta. And which one I will do? I will do this one. I will multiply by the by the, how you say in complex variable, or I forgot the name. I will multiply by cosine of theta plus 1 and cosine of theta plus 1. In this way, I have not altered the integral. So this is the integral of cosine of theta plus 1 divided by a minus b. A minus b multiplied by a plus b is a squared minus b squared. So it's a squared minus b squared. And a squared cosine squared of theta minus 1 is sine squared of theta. So this is the integral of cosine of theta plus 1 divided by sine squared of theta dd theta, the integral. Oh, now I'm in a better position to guess what is the integral of this. So let's go to write it here like this way. The division, the cosine of theta divided by sine squared of theta is cosine of theta divided by sine of theta multiplied by 1 divided by sine of theta. So let's go to write cosine of theta divided by sine squared of theta. This is cosine of theta divided by sine of theta multiplied by 1 divided by sine of theta. What is cosine of theta divided by sine of theta? The reciprocal of tangent theta. So it's cotangent theta. Is cotangent theta multiplied by 1 divided by sine of theta. What is 1 divided by sine of theta? Is secant theta. Is the reciprocal of sine of theta. Is secant theta. And I have to add 1 divided by sine square of theta, which is cosecant square of theta. So this division, cosine of theta plus 1 divided by sine square of theta, is cosine of theta divided by sine square of theta plus 1 divided by sine square of theta, or in other words, cotangent theta multiply by 1 or divided by sine of theta, which is cosecant x, plus 1 divided by sine square, which is cosecant square of x. The variable of integration is not the x, is the theta. So it's cosecant theta plus cosecant square of theta. So now we have to do this integral, right? Sorry that there is a mistake here. Cosine square minus 1 minus cosine square is sine square. But cosine of square minus 1 is minus sine square, so it will appear a minus sign here. So let's go to do the integral. So what we have said is that this integral is this thing. And now we have to find the antiderivative of cotangent theta, cosecant theta plus cosecant square theta d theta. And this will be, what is the function whose derivative is cotangent cosecant? I think that is cosecant theta. Cosecant theta. And what is the function whose derivative is cosine square of theta? Is cotangent theta. So plus c. So we found the derivative. We found the integral. So the integral of 1 divided by cosine theta minus 1 d theta is cosine theta plus cotangent theta plus c, and we make work this cosecant, is the c. Cosecant theta is 1 divided by sine of theta. 1 divided by sine of theta. Plus cotangent theta is cosine theta divided by sine of theta. So I make joining plus 1 plus cosine of theta divided by sine of theta plus c, and this is the integral. It's a little bit work, but you can practice a little bit more. The trick is here, is to multiply by 1 here. Okay, let's go to the next problem. The next problem, find the integral of 6 divided by the square root of 10 minus x squared, square root of 10x minus x squared. What I will do, I will try to write the denominator as a perfect square, the square of something. Let's go to do it. 10 minus x. 10x minus x squared. This is equal to, I need to complete the square. So is the square of the first, and it's 2 by 5. 2 by 5 is 10, so it's a 5 involved here, and 5 squared is 25. So I will add 25, and I will subtract 25, and I will write the same thing. And now I can complete the square. It will be 25, and this will be minus 5 minus x everything square. So it will be the square of the first, 25, with this minus sign. The square of the second is x squared. With this minus sign is minus x squared. Minus 2 times the first by the second, it will be 10x with the positive sign with this minus sign, minus minus. Okay, now I can work the integral better. And the integral will be the integral of 6 divided by the square root of 10x minus x squared ddx will be the integral of 6. We can put the 6 out of the integral, and will be 1 divided by the square root of 10x minus x squared, which is 5 squared minus 5 minus x squared ddx. And now we need to recognize that here there is an arc sine, because the derivative of arc sine of x, the derivative of arc sine of x, is 1 divided by the square root, or the derivative of arc sine of x divided by a is a squared minus x squared. So the derivative respect to x of arc sine of 5 minus x divided by 5 will be 1 divided by the square root of 5 squared minus 5 minus x squared. Oh, this is then arc sine of 5 minus x divided by 5. And the problem is solved. So it will be the integral will be 6 times arc sine of 5 minus x divided by 5 plus c, and when I make the derivative of this, the derivative of 5 minus x will produce a minus sign, so I'll better correct here. Now it's correct. It's minus 6 arc sine of 5 minus x divided by 5 plus c. That's all. Okay. Now this problem says solve the differential equation. The differential equation is 4 plus tangent squared equal y multiplied by y prime equals secant squared. So secant squared divided by 4 plus tangent squared. So the problem is asking you secant square of x. Who is the y? Which y you have to plug in here in order for the derivative to be secant square of x divided by 4 times plus tangent square of x. So the problem here is what is y? And y is the integral of secant square of x divided by 4 times plus tangent square of x ddx. Now this integral can be done by substitution. Let's name u equal tangent x. If we name u equal tangent x, the derivative of u respect to the x is 1 divided by cosine square of x or secant square of x is d du divided by ddx. So d du is secant square of x ddx, and this is what is sitting down on the numerator. So we name u as tangent of x, and we do substitution. The equation will read 1 divided by 4 u square, and in the numerator will be appear d du, secant square ddx. What is the integral of this? What is the antiderivative of this function? Is arctangent of u divided by 2. 4 is 2 squares, so it's arctangent of u divided by a. But this a square is 4. So a is 2. So the integral is done. It's arctangent of u, but u is tangent of x. So if arctangent of x divided by 2 plus c, and the problem is done. Now let's go to solve this problem, this integral. It looks that substitution will work. Let's go to try. U equal x squared plus 36. If u is equal to x squared plus divided by 36, d du ddx is 2x. So d du is 2x ddx that appear in the numerator. So the numerator will be d du, and the denominator will be 1 divided by the square root of u. So let's go to do it. So the integral of 2x ddx divided by square root of x squared plus 36 will be equal to the integral from 0 to 8. Oh, but I'm going to make a change of variable. I have to be careful. This is from x equals 0 to x equal 8. So this is not will be from 0 to 8. When x equals 0, u equals 36, because u is x squared plus 36. When x equals 8, u will be 8 squared plus 36. 8 by 8 is 64. 64 plus 36 is 100. So it's from u equals 36 to u equal 100. In this way, I avoid to reconvert the equation to the x. So 2x ddx is d du, and square root of x squared plus 1/2 is 1 to the 1 raised to 1/2, and the integral is 1 minus 1/2. The integral of 1 minus 1/2 is u minus 1/2 plus 1 divided by 1/2, so it will appear a 2 here. Divide by 1/2 is the same thing. So it will be 2 times u square root of, so this will be evaluate between u equals 36 and 100. So because u is a square root of, so it will be 2 times u to the 1/2. Evaluate between 36 and 100, so it will be 2 times the square root of 100 minus a square root of 36. Square root of 100 is 10, square root of 36 is 6, 10 minus 6 is 4, 4 by 2 is 8. So the result will be 8. Okay, let's go to do problem 10. This integral looks like an arctangent. If we name u equals 3x, we will make to appear the arctangent. So d du will be 3 times ddx, and the integral from x equals 0 to x equals 2 square root of 3 of 1 divided by 4 plus 9x squared ddx will look like the integral of ddx. ddx is 1/3 du divided by 4 plus 9 times u squared. U squared is 9x squared. So 9x squared is u squared. So plus u squared. And now it looks up. it looks now an arctangent. So this is the integral of a du divided by a squared plus u squared. This integral is arctangent of u divided by a, 1 divided by a. So it will be 1/3, 1 divided by a squared is 4, so a is 2, 1 divided by 2, multiplied by arctangent of u divided by a, of u arctangent of u divided by 2. So this integral will be 1/6 arctangent of u divided by 2, but u is 3x, so it 1/6 arctangent of 3x divided by 2. Or we have to evaluate this between x equal 0 and x equal to square root of 3. So it will be 1/6 arctangent of 3 by 2 square root of 3 divided by 2 minus arctangent of 0. Arctangent of 0 is 0, and arctangent of 1/6 arctangent of 3 square root of 3, I think these arctangent, who is the arctangent? So tangent of x, do like this, pi divided by 2 minus pi divided by 2, do like this. So I'm looking for the number 3 square root of 3, and I'm looking what is the angle. What is this angle here? It's something between minus pi divided by 2 and pi divided by 2, but which one? I'll better use the calculator and look the number. The number, let me see the calculator. Explain why y equal e to the x plus c1 is equivalent to y equals c to the ex. Why this is equivalent? Because this is e to the x plus c1 is equal e to the x multiplied by e to the c1. The law of exponents say that x to the n multiplied by x to the m is x to the n plus m. So n plus m is the x plus c1. So it's equal, and the x is the e. E to the n multiplied by e to the m is e to the n plus m. So now, what happened? If e to the x plus c1 is e to the x multiplied by e to the c1, e to the c1 will be a constant c. So I will call it c, capital C. This will be capital C multiplied by e to the x. So what I have explained why these two relations are equal. Let's go to the next problem. Okay, to solve this problem, we'll use this equation for the arc length that we have studied in class. The arc length is, the small arc length is the square root of 1 plus the derivative of the function with respect to the x squared by d dx. This is the small arc length, and the total length S is the integral of the square root of 1 plus the derivative of f with respect to dx s squared d dx from x equal, in this case, pi divided by 4 and pi divided by 2. So we need the derivative of f. We need to perform the calculation for this thing, for 1 plus the derivative of f. So it will be 1 plus the derivative of the natural log of the function y of x is natural log of sine of x. And the derivative y prime of x is 1 divided by the function sine of x by the derivative of the function cosine of x. So it will be cosine of x, y prime square will be cosine square of x divided by sine square of x. But cosine divided by sine is cotangent. And 1 plus cotangent square, 1 plus cotangent square of x. And 1 plus cotangent square of x can be founded by doing the operation 1 plus cotangent square is cosine square of x divided by sine square of x is equal sine square of x plus cosine square of x divided by sine square of x. So it will be 1 divided by sine square of x equal the reciprocal of the sine is cosecant. So it's cosecant square of x. So this is cosecant square of x. So now the arc length that they are asking me is s, the integral from x equal pi divided by 4 to x equal pi divided by 2 of the square root of 1 plus the derivative of f with respect to dx cosecant square of x d dx. And the integral of cosecant square of x, square root, is cosecant of x. So s is the integral from x equal pi divided by 4 to pi divided by 2 of cosecant x d dx, cosecant x d dx. And what is the integral of the cosecant x of x d dx? You have to do the same trick that we did with secant. If you do the same trick, remember, was multiply by, in the case of the secant, we multiply, in the case of the secant, we multiply secant x plus tangent x divided by secant x plus tangent x. In the case of the cosecant, we will multiply this by, instead of secant, cosecant x plus cotangent x divided by cosecant x plus cotangent x. If you multiply and you put the 1 here, the integral will be between from pi divided by 4 to pi divided by 2 of cosecant x multiplied by 1 by cosecant x plus cotangent x divided by cosecant x así plus cotangent x. If you multiply, you will have d dx, you will have the integral pi divided by 4, pi divided by 2 of cosecant square of x, cosecant square of x plus cosecant x, cotangent x, divided by cosecant x plus cotangent x d dx. And this is the natural log of cosecant x plus cotangent x. Now you have to evaluate this between pi divided by 2, and pi divided by 4. So I leave you to do it, okay? To prove that tangent of x plus secant of x is equal to 2 minus cosine of x, tangent of x plus secant of x, we have to prove that is equal minus cosine of x divided by sine of x minus 1. We perform an algebraic we perform some calculations, and the interesting thing is to look for the conjugate in this case of the numerator. So tangent of x is sine divided by cosine. Secant is 1 divided by cosine. They have the same denominator, so this is sine of x plus 1 divided by cosine of x. Now, when I have this equation, I have to multiply by 1. So I will multiply by 1, and I will multiply by the conjugate of the numerator. The conjugate of the numerator is sine of x minus 1 divided by sine of x minus 1. So this is a plus b multiplied by a minus b. A plus b multiplied by a minus b is a squared minus b squared. So it will appear in the numerator, it will appear sine squared of x minus 1. If you don't believe me, you do the distributive property. Multiply by cosine of x, sine of x minus 1, but sine of x squared of x minus 1 is minus cosine squared of x. So 1 cosine of x will cancel with another cosine of x of the denominator, minus cosine squared of x, 1 will disappear, 1 squared disappear here, and we have the solution. Okay, that's all.